Alright, so this whole video is going to be aimed at helping us to design an experiment because we are going to be designing our own experiments. So I want you guys to have a general understanding of some of the key concepts that we're going to be talking about when designing an experiment. Alright, so the factors that go into an experiment, I'm going to be using the word variable a lot. And factors in an experiment that can be changed are called a variable. Alright, so a variable is just something that can impact an experiment. Alright, that's something that can be changed. So examples would be like changing of temperature, the amount of light that's present at the time, the concentration. These are all variables in an experiment. These are things that can impact an experiment. All right, so in a variable, now there's specific types of variables. There are some variables, once again, a variable is just something that can impact an experiment, that we are going to change on purpose. We want to see how something changed. So the whole point of running experiments is to see, like, how does one thing affect another? I mean, that's really the basics of an experiment, right? Like, how does this affect this? How does one thing affect another? And so what we would do is we would call that thing that we're testing, that we're changing on purpose, we call that the independent variable. All right, so the independent variable is something that we change on purpose to see how it affects something else. We're like, hey, I want to see how this affects this. So I'm going to change this on purpose to see how it affects something else. And the variable that we're testing it on, the variable that we are trying to solve for, depends on the other variables. That's called the dependent variable, the one that we're solving for, the one that we're trying to figure out. So when I say how does this affect this, so really what I'm trying to do is I'm trying to see how does the independent variable, how does one factor affect another. All right, this is what we're solving for. So this a lot of times when we do an experiment, you'll know this ahead of time. Like, I'm going to change, if I want to test how high a ball bounces based on its drop height. Well, I know I'm going to drop the ball from 1 meter. Now I'm going to drop it from 2 meters. I'm going to drop it from 3 meters. I know what the drop height is initially. So if you know it ahead of time before even doing the experiment, that's your independent variable. I know how I'm going to change it. What I don't know, what I'm going to solve for, is how high it bounced. All right, so that would be my dependent variable. And it really only works. Really, I'm gonna really be busting your guys' chops because a lot of you guys are gonna try to change multiple things. It's just natural. You're gonna try to, like, what if I test this and this and this? And that's not what an experiment does. When you run a controlled experiment, we're working with one variable at a time. If we change too much, we won't know. You wouldn't know which variable is responsible for which. So like going to my bounce height example, if I drop one bouncy ball from 1 meter and then I go up to 1.5 meter or 2 meters and I drop a completely different bouncy ball at 2 meters, what's the, what happened? Did the bounce height go up? Yeah. Well, was it because of the ball or was it because of how high I dropped? You can see how the results can vary just by changing multiple things. We only want to change one thing. Everything else we want to keep the same. All right, we want to keep everything else the same, and that's called a constant. A constant is a variable that is kept unchanged. It is the same throughout the entire experiment. We want to keep every variable constant with exception to the dependent variable. That's the independent variable. We're solving for the dependent variable. Everything's the same except the independent variable. That's it. All right, so I'm going to give you a couple examples here. All right. Oh, I skipped it. Not yet. Just kidding. And so when you're designing an experiment, you're typically going to have two groups. Now, not always, but most of the time we're going to try to have two groups. One's called a control group. One's called an experimental group. All right. These two groups are identical except for one factor. That's the independent variable. A control group, and I'm going to use this term a lot as well. Like, what's your control group? It serves as a comparison. All right. You're using it as a comparison to the experimental group. Everything is the same except the variable being tested is removed. So basically, you're going to be removing the independent variable from this factor. I'll explain this in a minute. It's going to make more sense when I give you an example. Control groups are used to compare the results with the experimental group to determine the effectiveness of the independent variable. All right. And the experimental group is going to show the effect the variable we're testing has on another. All right, so like I said, this will make more sense when I go through it. I don't want to take too much time. All right, so in order to test the effectiveness of new vaccines, 50 volunteers are selected, divided into two groups. One group is the control group, one's the experimental group. Both groups are taking the exact same looking pill, excuse me. They're going to have the same size, shape, color, texture, but one group is getting what they call a placebo. They're getting a sugar pill. They think it's the vaccine, but they don't know for sure. right, because it looks the exact same. The other group is going to receive the vaccine. Now, the reason why they do this, because there's some evidence that shows that if people think they're getting better, they might change their lifestyle a little, they might do some certain things. So they want everybody to think they're getting the same thing. One group gets the vaccine, the other doesn't. The constants are the size of the pill, the shape, the color, the texture. Everything else is the same. The only thing that's being changed is one group's getting the medicine, the other one's not. All right. So once again, just to recap, independent variable, it's what we change on purpose. The dependent variable, that's what we don't know. It's what we're trying to collect data on. That's what we're trying to solve. And so in the example above, the independent variable, all right, that's the medicine. We're giving some medicine. We're giving some not. The dependent variable, well, did they improve? That's really what we're solving for. Does the vaccine work? All right, if it didn't work, then we'll know. But if it did, regardless, that's our dependent variable. That's what we're solving for. That was the whole point of the experiment, is to see, does this vaccine work? All right, and I'm going to give you one more example. So you want to try to figure out, let's say you're trying to grow some plants. You're going to have 100 orchid plants. You're going to try to figure out which amount of fertilizer will help it grow the best. All right, so you got 100 plants. All right, so you want to know if the orchids will grow best in weak fertilizer, medium concentration of fertilizer, high concentration of fertilizer. So we're going to figure it out. We'll state our hypothesis. All right, your hypothesis will be written as an if-then statement. Meaning if I...
Brad, if you're around, I need your...
it's basically an if-then statement. If I use a medium concentration of fertilizer, then the plants will grow the best. All right, so that's how we're going to write our hypothesis. This is actually incorrect the way this is written, but it's a testable prediction. So you're going to make your prediction, testable prediction. If we use medium concentration of fertilizer, then the plants will grow the best. So let's go through and let's figure out how we would set this up, because like I said, you're going to have to do this on your own. I'm not going to be helping you on this. So if we take 100 plants, divide them into 4 groups. Group 1 has 25 plants, receive plain water. Group 2 has 25 plants that receive weak concentration. Group 3, medium concentration. Group 4, high concentration. All right, you can see right away there are some constants here. All right. The same number of plants, it's the same type of plant. The plants will be watered daily over a period of a month. They're being watered at the same time. They're being watered the same amount. It's the same type of plant. We want to keep everything else the same. The only thing we're changing is the amount of fertilizer. All right, so you should be able to know which one is the independent variable. Obviously, is the amount of fertilizer, or whether it's weak concentration, medium, or high. All right, so then we're going to look at what is the control. Well, the control group in that scenario. Remember, that's the one we said the control group does not have the independent variable, meaning it does not have fertilizer. So that is our control group, and I'll explain why in a second. The experimental groups are the other 3, the various concentrations of fertilizers. All right. So the variables that are constant, once again, all receiving the same amount of fluid each day. They're grown in the same size pot. They have the same temperature. They're in the same environment. Because all those things, if we switched up the environment, we switched up the plant they're in, that could affect the growth of the plants. We just want to test the fertilizer so we know which plant truly, or which fertilizer is the best. All right, and so after a month, so we keep everything else the same. After a month, you run the test, you look, and you say, well, the control group grew an average of 15 centimeters. All right, so all the plants grew about 15 centimeters. The weak concentration grew 35 centimeters. The medium concentration grew 28, and the high concentration of fertilizer grew 10. So that actually hurts. When you put too much fertilizer into the plant, it actually stunts the growth, and that's why you run the control group, because you wouldn't have known that otherwise. If you would have just tested a high concentration and maybe a higher concentration, you'd be like, it grew 10 centimeters, that's good. Well, no, it's actually not. It's not good, because when you do it without any fertilizer at all, it grew 15 when you just watered it. All right, so it actually hurts the growth when the concentration is too high. All right, and so the result here would be that they grew best with a weak concentration of fertilizer. But the key there, once again, and the whole point, you're like, why are we talking about plants and fertilizers, blah, blah, blah. All right, the whole point is I'm just trying to emphasize how to perform a test. So we write a hypothesis as an if-then statement. And then when we go to test it, we make sure that we have various test groups, but we're only changing one variable. We want to keep all the other variables the same so we don't get our results skewed.